Okay, so this is the foundation paper question 3. Now it says here, the velocity time graph shows the motion of a car for a time of 30 seconds. So we just need to double check that across the bottom we have time, okay, and up the side we have velocity, because it is possible that this could be a distance graph, but this is velocity. Okay, so remember that velocity is similar to speed, it's meters per second. Now we can see that in the first 5 seconds of this journey, the velocity increases from 0 to 6 meters per second. And we could rephrase that by saying that the car accelerates. And because we've got these numbers on the graph, we can actually be very specific about the acceleration. We can work that out. And in case we're not sure how to do that, we can turn back to our front page and we can see that acceleration is the change in velocity divided by time, okay, or delta V. That's delta means change, V means velocity, divided by time. So if we turn back to our graph, we can see that the velocity changes from 0 to 6, okay. So if we put that into our equation, A is 6 take away 0 basically, because it's started at 0 and it ended up at 6, and 6 take away 0 is of course 6, and that takes 5 seconds. Okay, so the acceleration is 6 divided by 5, and as is good practice in your exams, to make sure you don't make any silly mistakes, I would advise to use use a calculator, don't use a ruler, use ruler for other things. Okay, so that's 1.2 meters per second squared, because acceleration is meters per second squared. Okay, so having done that bit of physics or maths, you could write a sentence, because this is a QER question that expecting you to be able to communicate well. Okay, so between A and B on the graph, the car accelerates at 1.2 meters per second squared for 5 seconds, reaching a velocity of 6 meters per second. Okay, so that sentence describes exactly what happens between A and B. Now, between B and C, okay, we can see that the velocity remains constant. Okay, so it neither accelerates nor decelerates. The vehicle travels at 6 meters per second between 5 and 20 seconds. Okay, so we could say between B and C, the car travels at a constant 6 meters per second for 15 seconds. Okay, because we've started at 5 and we're finishing at 20. Okay, and there's no calculations to do there because the graph is flat, it's a constant velocity. And then the final section of the journey, the car decelerates from 6 to 0, but this time the time period is from 20 to 30 seconds, which of course is 10 seconds. Now, if we use a similar equation to previously, except this time we need to remember that it's a deceleration, but we still tend to use the letter A. But to show it's a deceleration, the change in velocity is negative. Okay, so it's at negative 6 because it's starting high, going low. So it's minus 6, and it's not divided by 5 this time. This time is divided by 10 seconds, because between 20 and 30 seconds is a 10. Okay, so the acceleration is minus 0.10 0.6 meters per second squared. So it decelerates more slowly. Okay, and again, because this is a QER question, we need to write a sentence to explain ourselves. So between C and D, the car decelerates at minus 0.6 meters per second squared from 6 meters squared to 0 meters squared over a 10-second period. Okay, so these QER questions, not only are you expected to demonstrate your physics knowledge, but you are also expected to explain that in well-structured, well-written sentences. Okay, and there are marks available for the communication as well as the physics.